well, a little bit tougher tomorrow, but today we're going to talk about oxidation numbers, which tomorrow, I'll show you a little bit about that today, but tomorrow we're going to use oxidation numbers to help us balance reduction, oxidation half reactions, etc., etc. So we'll do that balancing tomorrow. That'll be a little bit trickier than probably just today, but we're going to talk about oxidation numbers. Oxidation state. The net charge that an atom would have if the electrons in a covalent bond belonged entirely to the more electronegative atom. So when you think about Chem 20, we do a little thing with polar compounds, polar bonds, right? And we talk about partial positive, partial negative, etc., etc. And we know that fluorine has an electronegativity of 4.0. Okay? If we pretended that, for example, those electrons that are being shared in that bond, if that electron basically belongs to the more electronegative atom, what charge or what state would that be in? And that's what we're going to talk about today. Okay? So oxidation numbers can be positive or negative values. There is a big difference between positive and negative, obviously. I know you know that, but there is a difference between positive and negative. They can be integers, aka positive negative 1, positive negative 2, positive negative 3, etc., etc. And they can also be fractions. And we know fractions because they're our friends. And I know that fractions are our friends because they both start with FR. Right? Fractions, friends. So they could even be fractions representing an atom's oxidation state. Okay? Common oxidation numbers. So when you look for oxidation numbers, or when you go to write oxidation numbers down, elements, any element by itself is 0. So lead, solid, 0. Okay? Cobalt, solid, 0. Yes? Copper, solid, 0. Chlorine, Cl2, gas, 0. Okay? It does not have a charge. It's an element by itself. Okay? H's are always plus, well, I shouldn't say this, but H's are 99% of the time going to be a +1. Okay? Oxygen's 2-. Okay? And you can kind of remember that because H always forms H+, right, usually. And O's, if you look where the O is, it's a 2-. So those are common ones given to those. If you are talking about charges on atoms, so any monatomic, any single atom ion or single ions, basically, atomic ions kind of thing. If you're talking about any kind of ion like copper 2+, then it's got an oxidation state of what we call 2+. Magnesium is a 2+, 2+. Potassium is a 1+, so 1+. Okay. Then we get into like things like fluorine, fluoride, F-, oh, it's a 1-. Chloride usually has a 1-. It doesn't have to though. Okay, so we just got to be careful with some of them. But any usually atom or ion by itself, either 0 for atoms, neutral atoms, charges go with that ion. Assign oxidation numbers to the atoms and ions below here. So let's go ahead and do that. Okay. Once again, you want to look for hydrogens or oxygens first. Hydrogen is a 1+, so you're going to write that down above it like so. Okay. Hydrogen is a 1+. Obviously, HCl is a neutral compound because there's no charge on this compound HCl. It's all combined together. So in this case, this chloride would have a 1, chlorine or would have a 1- associated with it. Okay. Any hydrogens or oxygens first. So that's a 1+, that's a 2-. That ionic compound is neutral altogether. So if you look at that, what does the sodium have to be? 1+, yes? Which kind of matches up with what we talked about, sodium ions, right? 1+. So you're going to actually put that right above each atom, okay? Now, oxygen is a 2-. Each hydrogen, therefore, makes sense, has to be a 1+. Okay? Each hydrogen, I have 2 of them in this compound, so 2 1+, 2 positive, has to go with the 2 negative. The important thing here to remember is you are assigning the atom, one atom, an oxidation number, not the combination of atoms. So each atom needs its own oxidation number, singular. Okay? And of course, if you look at this one, you might say, well, geez, there's no oxygens or hydrogens. Well, remember, that's going to form probably sodium chloride is an ionic compound. Sodium is a 1+, chloride is a 1-. Okay? So we'd have something that looks like that there. Okay? Good? Questions, anyone? For that one. Okay? What should I put above zinc here? What charge? Huh? 0. Okay, element by itself, neutral, 0. This is copper 2 chloride, so I'm going to use 2+ and a 1- here. This is copper solid, so 0. Zinc 2+, 1-. Remember, it is for each atom individually, not the combination of them. Okay? That's really important that we make sure we single out each atom. Each chloride is a 1-. And yes, I happen to have 2 of them, so therefore 2 negative goes to 2 positive. Okay? All right? Good? Next. 2 exceptions. So there's always got to be some exceptions, right? Because otherwise it'd be too easy. If you have a metal hydride, so like lithium hydride, sodium hydride, something like that, hydrogen can form a -1 charge in some cases. So it can take electrons if it has to. Usually that happens with the metal hydride. So in this case here, this would be a 1- and this would be a 1+. Okay? Metal hydrides are an exception. Like I said, 99% of the time, it's going to be, the hydrogen is going to be a 1+. This is the exception. Okay? In peroxides, well, if you look at this here, you know, it still kind of makes sense. That's a 1+ for hydrogen. However, if hydrogen's a 1+, if we put oxygen as a 2-, I'd actually have 4 negative and a 2 positive. And that, if you look there, that's a neutral compound. There's no charge on that. So in this particular example, peroxides, that's actually a 1- in that case. Okay, 2 positive, 2 negative, 0 neutral. Okay, H2O2. So those are the 2 you're going to have to kind of remember, special ones. How many questions are there going to be on that? I don't know. Maybe 1. Okay, I don't know. But maybe that's the one that's different between 100 and 96. Okay, I don't know. But you got to remember those. Okay, now, rules for assigning other oxidation numbers. All of the oxidation numbers in a molecular ion must add up to equal the charge on the molecule of the ion. So if you notice with that H2O2, it was 0. It was a neutral molecule. There was no charge on it. So I got to make sure it adds up to 0. Okay? If there is a charge, I need to make sure it adds up to that charge. All right? In compounds with 2 unknown oxidation numbers, so if you get to a compound and you don't know 2 of them, so let's say there's, you know, maybe there's no hydrogens and oxygens in it, maybe there's just 2, and you don't know which one's which or which one to start with, you start with a more electronegative atom. That's basically what that stuff says there. And assign it its normal charge that you would normally do. Okay? And we'll show you an example of that in a second here, but that's basically what this says. Take the more electronegative atom, you look on your periodic table, fluorine, of course. If you got fluorine, pick that one, because it's 4.0 and nothing gets better than that, right? Give that one a -1, because it usually forms a -1, and then the other one we'll just have to adjust based on that, okay? So, assigning oxidation numbers. Now, you look at the first one, you say, gee, there's no H's and O's. So, you look up Si, you look up Br, you look at their electronegativities, right, which is the number underneath the symbol there. We did this in Chem 20. And bromine is more electronegatives. Bromine usually forms a -1 charge according to, you know, it's in that -1 row basically, or column, I guess I should say. So if that's a -1, what does silicone have to be? A 4+, yes? Because each bromine or bromide, whatever, Br has a -1 oxidation state. There's 4 of them, so 4+ has to go with that. Okay? This one here is a little bit easier. This one does have an oxygen and a hydrogen, so we can start with those 2 there. This is a neutral molecule. Most of you guys are thinking probably chlorine. Maybe that should be a -1. You know what? Maybe it should. Maybe it is in some cases, but it's not in this case. Okay? This is 8-. So you always start with the hydrogens and oxygens. 8-, that's 8 minus plus 1, 7 minus. So that's a 7 positive. Okay. And yeah, if you change that to HClO3, hydrogen chlorate, then guess what? Chlorine's a 5 plus. And then it can go down to 3 plus and a 1 plus. And it could be a 1 minus. It could be a 0 if you're talking about chlorine. Okay? So there's lots of different options here. You can't just assume. You have to kind of work through these. Here, oxygen. So I'm going to start with that one. Let's see. That's a total of 14 negative, yes? Because I have 7 of them. 14 negative. This one here has to be, therefore, well, 12 plus, right? Because I need a 2 minus charge here. So each one has to be a 6 positive. And you can write them either way, 6 positive or positive 6, whatever. Maybe 6 positive is what I should have wrote there, but yeah. Yep. Yeah. A lot of them can. It doesn't have to be just chlorine. A lot of them can have different charges, so you do have to figure, you can't just be like chlorine, that's a -1, I'm done. That's not the case, okay? You always got to start with oxygen, hydrogen if you can. If you can't, then it's kind of like the first example, you got to go based on a more electronegative atom, okay? All right, good? Now, mine got cut off here, but yours is fine. It says basically identifying redox reactions by oxidation numbers. Okay, so this is kind of what we're going to lead into tomorrow a little bit. This is kind of the first introduction. When the oxidation number of an atom or ion changes during a chemical reaction, then obviously that chemical has gained or lost electrons. When the oxidation number changes, it's telling you that it's either gained or lost electrons. Okay, if it's gained or lost, guess what? You probably have a redox reaction. Okay. You probably have a redox reaction. So oxidation, of course, we know this already. I kind of tried to get you on that track earlier. If you remember, I said we're going from, if you look at this oxidation, we're going from a 0 to a 2 plus here. Yes, oxidation state, oxidation numbers. Yes, okay. Element by itself. You might want to write those down even. 0 to 2 plus. We're going up in charge, right? How does that happen? How does iron become iron 2 plus? We have to lose electrons or write them on the right-hand side. Therefore, this would be an oxidation half reaction, obviously. Okay? You're going up in charge, so it's being oxidized, 0 to 2 plus. Okay? It tells you down here, it's fine. That's true. Basically, all you have to know is, you guys know the number line, okay? We actually have that on here for you. But if you're going up in numbers, -2 to 2, 0 to 2 positive, if you're going up in numbers, that's an oxidation. Okay, that's being oxidized. If you're going down in numbers, I told you this before, if you think about this, if you're going down, you're being reduced, therefore it's reduction, right? So here, you're going from a 0 to, in fact, a 1 minus. Remember, it's just for the chlorine, or that, in this case, the chloride. So that's actually a -1 there. It's not a 2 minus or anything like that. That's going from 0 to a -1. Yes, you do have 2 of them. That's how that works out. This is being reduced. You're going down. 0 to a -1 is going down the number line, number chart. Therefore, it's being reduced. Okay, and this would be your reduction in this case. Okay, so any numbers that go down, those are actually the easiest ones, right? Anytime you see numbers going down, you know that's the reduction. And if it's a reduction, guess what? You need to have an oxidation that goes with it. Yeah? So then you can pick that one out after. Okay? My chart didn't work out as well as yours, but basically this is what it says here. If you have a reduction, you are going down the number line, and oxidation, of course, is going up the number chart. Okay? And that's what it said. Mine didn't turn out very well here, but that's what it says there. Okay? Obviously, guys, this is nothing new. We talked about this. In a redox reaction, the OA is being reduced, right, for the 15th time. And, of course, vice versa, the RA is being oxidized. Okay? If it's being reduced, the number is going down, the charge is going down. If the charge is going down, that's your oxidizing agent. Okay? If the oxidation state number is going down, it's your oxidizing agent. If it's being reduced, or sorry, if it's being oxidized, your oxidation state number is going up, therefore it's your reducing agent. Okay, and like I said, we know that already. Same thing applies. Same thing with the number line, right? So a chemical reaction is not a redox. This is important. Okay, very important actually. We'll probably give you some type of question, or you'll get some eventually. A chemical reaction, just because it's in the unit doesn't mean it has to be a redox reaction. Okay, so if there is not a redox reaction when there is no change in oxidation numbers. So sometimes there is no change in oxidation numbers. It is not gaining or losing electrons. It's not a redox reaction. You can't do any reduction or oxidation with it. Okay, you can't write out half reactions because nothing's happening as far as electrons being transferred. Okay, so the question here is, for example, is methane a redox reaction? Combustion. Well, let's see. CH4 and oxygen is carbon dioxide gas and water. Okay? You can balance it if you wish to, okay? But it's not asking me to do anything with this. I'll show you actually, we'll actually balance this tomorrow with oxidation numbers is something we'll do, and I'll show you a little bit of that today as well. But you don't have to balance it. All the question is this a redox reaction? Okay? Most of the redox reactions are single replacement, decomposition, single replacement, decomposition, and formation. Those are easy ones to tell. After that, you will have to do the following to determine. Okay? Those are the easy ones to determine. These ones are a little tougher. Okay? So when you look at this, you say, okay, well, hydrogen is a 1 plus. So I'm going to write that down. Well, if hydrogen's a 1 plus, I guess this has to be a 4 negative, 4 minus oxidation state. Atoms by themselves, oxygen, 0. I got an oxygen over here, that's a 2 minus. That's a total of 4 minus, so that's a 4 positive oxidation number. Here I got my water, good old water, 1 plus, and a 2 minus, of course, for water. Always. Okay? So the question is this a redox reaction? What do you think? Yes or no? Huh? Is it? Redox reaction. Sure it is. Is the oxidation numbers changing? Yep. So it's a redox reaction. This one's going from a -4 to a +4. Okay? And you're going to balance it tomorrow based on that. I will tell you right now, look, if it's going from -4 to +4, what's happening? Is it being reduced or oxidized? Quickly. Oxidized. So can I say this? Sure. Okay, what about the other one? What's the other thing going on here? Oxygen's going from 0 to 2 minus, right? Now, sometimes I do it differently, but I kind of gave myself that arrow there. So, that's going from a 0 to a 2 minus. That's going down. That's being reduced. So this is your oxidizing agent. Okay? And then we're going to balance the reducing agent, oxidizing agent tomorrow. Okay, so stick around. Don't miss tomorrow. Now, one thing I have to mention to you this. Listen, CH4 is all of this. Yes, the carbon, okay, if we're looking at the carbon, yes, it is actually going from a 4 minus to a 4 positive. But you have to consider the whole thing. Carbon's not by itself here. So the reducing agent is CH4. All of it is the reducing agent. Okay? It is the reactant, right? Just like before, you had this and this was the reducing agents. Okay? That's all the reducing agents. It's not just part of it. It's just not this atom. It's all of it. Yes, the C is going from a 4 minus to a 4 plus. Yes, it is. But it's part of those two compounds. Okay? All right? Assign oxidation numbers to identify the OA and the RA. So here we go. OA and the RA. Actually, I'm going to let you guys do this one. You guys go ahead and do. So, wherever you wish to start, doesn't really matter. Obviously, you got to get all of these numbers here. So, I'll start here. 2 minus. Dichromate, by the way, is a very common one. You're probably going to do that a couple times in your chemical career because it's really good at usually gaining those electrons with an acid. In fact, if you remember, I think that might have been one of your ones you got today, I think. Maybe, I don't remember. Maybe it was the other class, I don't know. Anyway, 2 minus, that's 14 minus. These would have to be 6 pluses to get the 2 minus charge there, yes? Okay. This is a 1 positive. It's not hydrogen. It's not H2. It's not an element. It's got a charge, so 1 positive. This is a 1 positive. This is a 2 minus. This is a 1 positive. So that's 5, 6, 2 minus, so that's 4 positive. Each one of these has to be a 2 minus. Okay? And like I said, you're going to have to do that. Please be careful when you do this. Get a good calculator if you're not sure. One that will do this for you kind of thing. Okay? 3 positives, 2 minus, 1 positive, of course. And then here we go. 1 positive, 2 minus, 1 positive. That's 3 and 1 is 4 positive for the hydrogens. And then I got 4 negatives for the O's. So I'm not going to, like I said, these two have to be the same. So those are both zeros. Okay? All right? So what we're going to do tomorrow is this. I'm going to say, okay, look, chromium goes from a 6 plus to a 3 plus. Yes? So what's happening? It's being reduced, right? So that is being reduced, you could say. Therefore, this is your oxidizing agent. The entire thing, of course, is your oxidizing agent. Okay? And then tomorrow, it's a little more. There's a little bit more to it than just that. So don't be like, oh, I know what's going on. I'm not showing up tomorrow. Okay? So don't be like, yeah, this is pretty easy. It's a little bit more involved. We're gonna do some fractions tomorrow. It'll be fun because fractions are a friend. Then you look here and you say, what else? Well, look, the carbons are going from a 2 minus to a 0. So of course, 2 minus to 0, that's going up. So that is being oxidized. Okay, and therefore this would be your reducing agent. Once again, the entire thing would be your reducing agent. Okay. And then tomorrow we're going to balance those two out. Okay. And that's what we're going to do tomorrow. We're not going to have enough time to do the last part here, so I will do disproportionation ones with you tomorrow and show you how that same one leads to both. I will give you a worksheet for tonight, and that'll be it.